is my big fish tank, and I've got a bit of a problem with it. To keep the plants healthy and growing, the tank needs quite a lot of light. But the downside of that is that green algae slowly starts building up on the inside of the glass. Now, I could just go online and buy one of those magnetic aquarium glass cleaners, but they're actually pretty expensive, and honestly, what's the fun in that? So in this video, I'm going to design and 3D print my own magnetic aquarium glass cleaner. The challenge is that this tank has 10mm of glass, which means the magnets need to be pretty strong if the cleaner is going to stay attached and move smoothly across the surface. So let's jump in Fusion 360 and start designing this thing. So I'm gonna start this project with a sketch, and I'm gonna build my sketch on this top plane. And first of all, I want to know how big my magnets are. And the magnets I'm going to be using are 10.47mm in diameter and 550 in thickness. So I'm going to start with a circle right in the center of this sketch, and I'm going to do the first middle circle, which is going to be 11mm in diameter, because I want to make it slightly bigger so I don't have to struggle to push the magnets into the 3D print. That's my first circle, 11mm, and let's make 6 more. So I'm gonna go a bit higher, and I'm gonna make another one of 11mm. This second circle, I want to create a circular pattern out of it. And I'm gonna select it, select the circular pattern, and select the middle, and I want to do 6 of them. So now I have everything spread out, and let's create the first base. So at the moment I'm working on the outside of my cleaner. So I'm making another circle that's gonna include all of these little ones, and I can finish this sketch at the moment. So this is the main sketch, which is going to help me build both the inside and the outside of this cleaner. So now that I have everything laid out, you guys can use whatever size magnets you have, or whatever size magnets you can find on Amazon or wherever, and just adjust to your measurements. So first of all, I want to take this without all of my magnets holes, and I want to extrude this a bit more than the thickness of the magnets. So my magnets are 550 thickness. I'm going to extrude them at 6. So that's going to be the place where I'm going to drop my magnets. Now, if I go back onto my sketch, let's make the sketch visible. I can now select everything, including the holes for the magnets, and I can simply extrude this by minus 0.4mm, which is 2 layer heights at 0.2. So I don't want to have too much space between the base of this holder and the magnets themselves, because as soon as you increase the distance between the magnets lose a lot of power. So I want to keep the magnets as close as possible to each other. So now that I have the bottom of this holder, I have the space for the magnets, let's create a handle. So for this handle, I want to create another sketch, and I want to create it onto this plane. And for this, I just want to create a very quick and simple shape that's going to help me hold it in place. So I'm going to take a fit point spline, and I'm just going to create a very basic holder to hold my thing in place. So that should be fine. I'm gonna drop this a little bit because I don't want to have that. And let's make another line because we want to close this so we can have a profile, and then we can revolve this around the z-axis. So let's finish the sketch. Now we have a profile. We can simply take this and revolve this around the z-axis. So, or we can choose this line. So that's the holder, which is going to be on the outside of the fish tank, and I think that should be fine. If I'm not happy with this, I can just go back and double click this sketch, and I can just modify it however I want. So I'm gonna just make it a bit like that, maybe turn this around for a second. Let's see, there we go. I think that should be fine. So now we have a holder with some space for magnets, and this is just fine. I'm just gonna save it as it is, and I'm gonna start working on the inside bit. Now that I've saved this one, I can rename this body and call it outside. And I'm just gonna hide this one and make the first sketch visible again. Now this sketch I'm gonna be using to work on the bit that goes into the fish tank. And this is gonna be pretty much exactly the same thing like I did on the inside. I'm gonna take this surface and I'm gonna extrude this by 6 millimeters. Then I'm gonna go and I'm gonna hide the body for a second and select everything. Let's make the body appear again. And I want to extrude this again by 0.4 millimeters. Well, it's gonna be minus 0.4 millimeters. Enter, and there we go. We have everything that we need. We just need to create a sort of a dome, and the reason I'm making a dome on top of this is mainly because in case it disconnects from the outside bit, I want it to float. So let's create a way for this to float. So I want to create a new sketch. We're going to do exactly the same thing that we did on the other side, but we're going to create a dome. So let's go with a straight line, and I'm going to start from the top of this in the middle, and I'm going to go all the way to the end. That's one of the lines. Now I'll take another line from this middle to, I don't know, maybe 25. Let's go 30 millimeters. Maybe it's too much. Let's go for 20 millimeters. I think that should be fine. And let's take a fit point spline. Start from here, go there, and go somewhere there. And that should be fine. Let's make this closer to what I needed. And I want to make this straight also, so we have a nice transition between the straight line and the curvature, and that's okay. And maybe I'm gonna lift this up a bit. There we go. I think that should be fine. So now if I select this profile and I revolve it, and I'm gonna choose the axis this line, that will give me a dome on top of everything. And when I 3D print this, it will be 3D printed with just a little bit of infill, and hopefully the air that's trapped inside is going to give it enough buoyancy to float. So let's export this also, and let's import everything into Bamboo Studio and see what kind of settings we're going to use. So these are my pieces which I want to 3D print, and I'm printing these two on my Bamboo Lab P2S, and that's just simply because I want to test the quality of the time-lapse, the quality of the camera actually, and see what kind of time-lapse can it do. So let's see what kind of settings we're going to use here. Let's start with standard quality 0.22, and let's slice this print and see what it does and what we need to change. So starting with the 0.2 millimeters, we can see that we have quite a bit of infill, and the print is going to take 2 hours to print. So let's do some changes, and I think with this specific print we're going to sacrifice a bit of time for some more quality, and we also need to sacrifice a bit of material because we want to make sure that no water gets to these magnets. So let's increase the wall loops. I'm going to go for 4 wall loops for this print, and I want to increase the quality. So I'm going to do initial layer height, I'm going to put 0.1. Altogether layer height is going to be again 0.1, and I want to go to strength, and I want to decrease the infill density to 5%, and instead of the grid pattern I'm going to use the gyroid pattern. Okay, now let's see what other things we need. Quality, I'm not bothered too much about the seam position, and let's slice this and see what happens. And I think with the 0.1 millimeter layer height it looks actually pretty good, and 2 hours 33 minutes, I'm fine with that. The only thing we need to do now is find that top layer of the magnets and add a pause to that. So we're gonna go to find that layer, and let's have a look at one of the magnets, and I'm gonna just scroll down to through this until that last layer before it caps off. So that would be layer 65 in my case. I'm gonna go down to 64, right click and add a pause. So now when my 3D printer prints all of this, when it reaches this level layer 64, when it reaches this layer 64, it's gonna stop. I'm gonna insert the magnets, and then I'm gonna tell it to carry on basically. There we go. I think that would be everything that I need for this print, and let's send it and see how that's gonna behave. One more thing I forgot to do is I forgot to enable the time-lapse. So I'm gonna go time-lapse, traditional, I'm gonna go smooth, and I'm gonna slice this again. And I'm actually very curious on how this time-lapse is gonna look like. If it doesn't look really good, I'm still gonna keep it as an experiment, but I'm just gonna use my phone as usual to film the rest of my videos. At the moment I want to use this camera and see just how everything comes out. So let's print this plate, and I'm gonna use this printer, and I want to use this purple PLA which I have loaded into the AMS, and I want to do time-lapse on. I want the flow dynamic calibration auto everything, and let's send it and see what it does. So the time-lapse didn't come out as good as I hoped, and that means from now on I'll be sticking to my A1 and I'm going to be filming all my time lapses with my phone. And because the magnets are just not strong enough to go through 10 millimeters of glass, I'm going to be using this fishing magnet to save the day. And it seems to be working, which means I will have to come back and revisit this project in a future video and maybe make a better and stronger aquarium cleaner. I will be making some more 3D prints for my fish tanks. I need to make some lights, I need to make a few brackets, and if you guys want to see those videos, just give me a message in the comment section below, and if there's enough interest I will be making some more videos. And as always, if you like this type of video, don't forget to like and subscribe. Thank you for watching. Until the next one, happy printing.